Hello, my name is Lewis. I'm a QTS data center technician, and today I'm going to show you how to set up a two-jumper reference using the Corning light meters and how do you test using a patch panel. First things first, we need to set up our source. Our source for single mode is going to be set to 1310, and we can change through the different power settings using the middle button function here. You can change it to 1550, 850, and 1300, which those are used for multi-mode connections. Again, we have a multi-mode port and a single mode port here at the top, so make sure you're plugged into the right one. Secondly, we need to make sure that our meter is set to the correct wavelength as well, using the same A function button here. On the meter is going to be the first button, and the numbers will change here at the top, so scroll through them until you find 1310. Make sure that the meter matches the source. Next thing I want to do is take a coupler, plug in one side, take my second patch cord, plug that in on the same side as the cable that's coming from the source, so that light is passing through simultaneously on the same line. And then we're going to plug in to the top of our meter, and then we're going to get some readings initially. And as we can see here, we're getting a negative 0.007. This is dB that is reading, and dB is for insertion loss. So as of right now, we have 0.09 dB loss introduced into our cable that we're testing. The top number that you see is our reference, which is at a negative 4.57. And when we're talking about dBm, again, we're talking about optical power, raw power coming from a source and what we're receiving into our meter. So we're going to hit reference, hold down reference, get all that loss out of the cable and into our reference, so that when we go to test, the meter understands that all the data that's coming in is now actual loss of light and optical power. So we have our reference is set. We're going to disconnect from our coupler here. We're going to plug our source into one port of the patch panel, and panel B will be representing one panel in an enclosure somewhere in a building, in a closet, or whatever transport room that this equipment may be in. We're going to plug up the other end to our secondary patch panel on the other side of our cable, and we're going to look at our meter, and we're going to initially see that we're getting some readings back. And general rule of thumb, when we're doing our fiber connections and we're testing for dB loss, we want to stay within a certain range that we're delivering to customers. And right now we're getting a negative 0.17, which is a very good number to have. Rule of thumb, you want to be anywhere between 0.50 dB, 0.75 dB or less. So obviously we're below that, so we have good readings on this particular port, and we would just do the same for the other pair on the same port. Move it down and take a reading there, and we can see that we're getting a negative 0.46, and this is optimal. This is very good light passing through these connectors. So in a scenario where we just want to measure optical power passing through those connectors, we can just change our function on our meter side now to go ahead and give us dBm reading. We can hit it one time in the middle, it'll change it, and as we can see now, the raw power passing through those connectors is 4.13 dBm. So this is how you would change from insertion loss test to an optical power test using the Corning light meters. thank you for watching. Hit me up at louis.lugo@qualitytech.com if you have any questions. Thank you.